Hello everybody. So in this video I really just kind of want to go over a simpler implicit differentiation problem and then one that's a little more complex. So for the simpler one, let's do this. X squared plus y squared equals 16. So this is a circle. Equation of a circle, radius 4, centered at the origin. So let's find, here's what we're going to do. We are going to find dy dx. And we're also going to find the second derivative as well. I'll write that here. Find the second derivative. Okay. So, keep in mind what we said last time, which is that dx is 1. And dy dx is exactly that. It's dy dx. It's y prime. It's the first derivative of y with respect to x. So here we go, right? I'm going to apply the derivative operator to both sides of my expression. So I'm taking the derivative of the left, I'm taking the derivative of the right. If I take the derivative of the left-hand side, derivative of x squared is very simple. It's just power rule. 2x and then dx is 1. Plus, and then here we are, right? Y squared. So first we have something squared. So we have 2y to the power 1. And then we move inside of the variable y. And remember, y is a function of x. Y depends on x. So if we're taking the derivative with respect to x, we're going to have dy dx. Okay? There's the left-hand side. Right-hand side, derivative of 16 is 0. All right. So again, we're trying to solve for dy dx. We're going to move all terms non-involving dy dx to the other side. So I'm going to subtract 2x. Subtract 2x. If I do that, the 2x goes away on the left-hand side. And I get 2y dy dx equals negative 2x. Negative 2x. Okay? And, we're trying to solve for dy dx, so just divide both sides by 2y. And boom, boom. So we get dy dx equals negative x over y. And this is going to happen for any circle. And you know what? Before we go too crazy, let's actually think about what that means. Okay? So it's supposed to be a circle. It's definitely not a perfect circle, but it's close enough. Let's look here. If I were to draw a tangent line, like I'm getting ready to do, if I draw a tangent line, let's see if I can do this without messing it up. Yeah, that's pretty good. Nope. Okay. We can clearly see here that the slope is negative. Okay, and we're in the first quadrant, which means x and y are both positive. So look here. If x and y are both positive, we get a positive, but then there's a negative here, which is exactly what we would expect. Now, let's look over here. Okay. If I draw a tangent line here, then here x is negative, y is positive. Okay, so we get a negative here over a positive here, but then there's a negative sign. So this overall, x over y, is negative, but then negative times a negative is a positive, which is what we see here. Let's keep going. Third quadrant, if I draw a tangent line, I get something like this, and we can see that this slope is negative. In the third quadrant, x and y are both negative. So negative over negative is a positive, but then throw a negative sign on there and it's negative, which is what we see here. And then unsurprisingly, if we come over here and draw a tangent line, we can see that the slope of this line is positive, and that's perfectly fine because x is positive, y is negative. So we get positive over a negative, so overall this is negative, but then this negative sign out here makes the result dy dx positive. Okay, so this is just a quick little insight into what this result actually means, dy dx equals negative x over y. All right, sweet. Now we can do the second derivative. Let's do it. So let's keep in mind that dy dx is negative x over y. And let's keep in mind that x squared plus y squared is 16. Condition 1, condition 2. Okay. Now if I want the second derivative, what I'm going to do is I'm literally going to apply the derivative operator to both of these sides because I already have the first derivative. If I want the second derivative, I operate on the first derivative with dy dx. Okay? So d by dx of dy dx on the left-hand side, and then I want to do d by dx of my result negative x over y. Okay? Left-hand side, just sort of think about this like algebra. You have a d and then a d. The two d's there is going to give d squared. And then there's still just the lone y. And then dx times dx, that's the dx squared. So this is where this type of notation comes from. Remember though, it's not algebra, it's derivatives, right? It's the derivative operator twice. Okay, good. And now over here, the derivative of this expression. Well, this is a quotient, so we have to use the quotient rule, right? So, so the derivative of the quotient is bottom derivative of the top minus top derivative of the bottom over the bottom squared. Okay, so my gotta love interruptions. Okay. Yeah, where was I? Yeah, the top function, right? The top we can just say is negative x. So the derivative of the top with respect to x is just going to be negative 1. The bottom function is y. So the derivative of y is just going to be dy dx. And let's remember that dy dx is literally negative x over y. Okay? So let's plug all this stuff in. So bottom is y. Derivative of the top, negative 1. Minus the top. Top is negative x. Times the derivative of the bottom, negative x over y. Over the bottom squared, so over y squared. Okay? So now we get negative y. And how many negatives are here? 1, 2, 3. So negative times negative is a positive, but then there's a third negative. So minus. And then x times x, x squared over y. And this y is negative y is over 1. All that's still divided by y squared, which we can further show as a complex fraction, y squared over 1. Okay. Now, I'm going to work with this. We have two fractions with different denominators, so we need to get a common denominator. Least common denominator is going to be y. And we need to multiply the top and bottom of term number 1 in the numerator by y. Okay? So if we do that, we'll get negative y squared over y, if I multiply top and bottom by y, minus x squared over y, over y squared over 1. All right. Then, let's see, this becomes, denominators are the same in the numerator, negative y squared minus x squared over y squared over 1. Okay, so just doing some algebra here. Okay, now what I want to do is I'm going to actually factor a negative from the top here, and I get y squared plus x squared if I do that over y, and I'm going to go ahead and play the complex fraction game. So fraction over a fraction, you kids like to say keep, change, flip. We can do keep, change, flip. You know, I like to say dividing by something is the same thing as multiplying by its reciprocal. That's the way I like to think of it. But whatever works, right? Okay. So there's that. Now here's something interesting. Here we have y squared plus x squared. Okay. Now in the very beginning, I said, hey, remember that x squared plus y squared is 16, right? So anywhere we see x squared plus y squared or y squared plus x squared, we can replace that with 16. Okay. So I'm going to do that right here. So if I do that, I get negative, and then the negative of y squared plus x squared, which is negative 16. And then y times y squared is y cubed. So negative 16 over y cubed is going to be the second derivative of the circle, which is interesting. It's interesting that the second derivative only depends on the y value. So there's that.
Teachers, please come to the